we're continuing on 1.8, the second half of this, and we're doing negative infinity, but the rules still apply, the math still works. For instance, if we were to divide all of these by x squareds, divide by x squareds, because that's the denominator's degree, what would happen, just to change colors, is the x squareds would cancel here. Since it's bigger on bottom, that's going to be 0 with a negative infinity. This is 0. The x squareds cancel here. This will be 0. It's bigger on bottom, bigger on bottom. So the answer is just 2. So it does not matter that it's negative infinity for this problem. Now it does when we look at the slant asymptote problem. Now it should make sense. But if we did the same process as what we talked about before, and we divide everything by x, the denominator's degree, divide by x, divide by x. So this would be canceling, this will give you 0, this will give you 0, this will give you 1. One of these will cancel. So what we really have is the limit as x goes to negative infinity of x plus 3 all over 1. Well, if we plug in, do our substitution, we would get negative infinity. I guess I think I'd be fine to have an equal sign, but I'm going to try and keep everything consistent. Well, if you add 3 to negative infinity, you still get negative infinity, which is agreed upon with the graph. This y value is going infinitely down for this curve. So that's where negative infinity comes into play. So there's a few times that negative infinity makes a difference. I wouldn't really like to write down rules, because I think it's better to just understand really the math that goes into it. Now you can use your pre-calculus rules, and you could look at this and say, okay, well, the negative infinity doesn't matter because the exponents are the same, you know, your Eats DC rules, and so you can just divide your leading coefficients. So the answer should be negative 2/3. I'm not going to make you do the pre-calculus work, or sorry, the calculus work to explain why it's negative 2/3. You know, because you'd be dividing everything by x squared, divide by x squared, divide by x squared. So those would cancel, these would be zeros. Now my circles are starting to get ugly. You know, divide by x squareds, divide by x squared. So one of those would cancel, divide by x squared. So after all these zeros would cancel out, you'd be left with negative 2/3. Here's one where it does matter because it's that bigger on top. So it's a slant asymptote, excuse me. So as you look at this, you can divide everything by x. Divide by x, divide by x, divide by x. So like this would cancel. This would, when you do the limit, would equal 0. Divide by x. This would equal 0. Divide by x. So that would cancel. I think what would be important about this, though, is as you look at that problem, it's negative 1 in the denominator. Negative 1. So you'd have 2x minus 1 in the numerator. But if you double negative infinity, you're still going to get negative infinity. But now you have negative infinity over negative 1, and a negative over a negative is positive infinity. So I think working through the math makes more sense than just memorizing rules. Now, it would be awesome if that's all we have to do with, I guess, this work. But we also throw in square roots into the problem. Now, just as a reminder, there is the no calculator portion of a test. So just because you can type this into a graphing calculator and see does not necessarily mean in May you will have that luxury. But this is f of x, and this is what the graph of f of x looks like. If you're sitting there and saying, whoa, this horizontal asymptote got crossed, that's okay. And if you don't believe, I'm going to show you the work for the horizontal asymptote, by the way. But if you were to plug in 0 in for all of these x's, you'd have negative 2 divided by 1. So it does cross the horizontal asymptote. That is perfectly fine. But if we look at this, you can definitely tell that the left end behavior goes to negative 2, and the right end behavior should be going to the positive 2. So there's a main difference between these. One's positive and one's negative. And the best way I can explain this is if you think about when you're solving a problem. So like we have the square root of x squared. Like I'm just going to jot it down right here because it's right here. Is anytime you square root a value, there's two scenarios, especially when you're solving for a problem. Is you have the positive version and you have the negative version of that x. For instance, if we have negative x right here, well, when you square it becomes positive, and then you can square root that value. So that's why we have two different scenarios, and the main difference is this negative sign. See how the negative one had a negative and the positive has a positive? Now that's not always the case. You have to pay close attention. So technically what we are dividing everything by is the power in the denominator, which is just dividing by x, because the square root of x squared. So like I'm going to write it slightly different. Let me actually write it out this time. I think I have plenty of time. I'm going to divide by x in the numerator minus 2 over x, and in the denominator I'm going to divide by like each one individually by x squared. Now remember, this is the square root of x squared, which is equal to x plus 1 over x squared. So what we're looking at is this will cancel. Let me change colors to really emphasize the next step. This will cancel. This is equal to 0. This will cancel. This will equal to 0. And the square root of 1 in the denominator, how about I just write it? Equals 2. So this matches that work. And then going back to my other work, I'm really doing the same thing, except when you have a negative infinity, what you want to think about is that we want to examine the negative of that square root in the denominator. I forgot to write over x squared. But all the work is pretty much the same, except because we're looking at negative infinity, we want to stick a negative in front of that. This is 1, this is 0, this is just 2, 2 times 1. So we're looking at 2 divided by the negative square root of 1, and we get negative 2. And this answer matches up with that. I'm not sure why we flipped them around. Hopefully that did not confuse you. But this is the work to explain that. So now we just have problems to help you understand. It's really the same thing. Because it's negative infinity on this, you want to practice sticking a negative in front. And we're dividing by x squared, the square root of x squared. And then in the top, it's just dividing by x. So this cancels, this cancels, this is 0, this is 0. So what we're left with is 3 over negative square root of 2. And in calculus, they actually let you leave the answer like this. But if anybody wants to rationalize, feel free to. That will not get marked wrong. And then don't forget that this means that there's a horizontal asymptote at that value, y equals that. And as we look at this one, really this similar work, but if we look at, if we were to divide by the denominator here, you're going to come across an issue because we're going to divide by x on top, and in the denominator we want the negative. I don't know if I should put the negative there, but that's where I'm putting it. Of 3x squared over x squared, because the square root and the square would cancel out. I hope this is all making sense. So like these would cancel, this would cancel, this is 0. So what we have is negative infinity. Now I'm substituting in, putting an arrow because they just don't like when you have negative as an answer. I think you'd be fine if you wrote equals, but I'm going to put an arrowhead. Negative infinity plus 2 over the negative square root of 3, which I don't know how familiar, again, you are with like infinities and operations, but negative infinity plus 2 is just negative infinity, and when you divide by a negative, you're going to get a positive infinity. So this is your end behavior. As this graph goes infinitely to the left, the function's going infinitely up. And I believe you should be ready to work on the homework now. So that's the next slide.